open up your binder.
Wait, what?
CO19.
Oh.
Let's follow the plot. And we're going to talk about today something called linear functions. And so we opened up this unit talking about relations, which is any collection of ordered pairs, whether it's from an equation or a table or a graph or whatever. Then we kind of specified that and brought it down to functions, right? Which are specific relations where x does not repeat itself. Okay. More specific, just wait a little bit.
I know that's right.
More specific would be a linear function. Okay, and you might be able to guess what a linear function is based on the title. What would you surmise a linear function looks like?
It involves a line.
It involves a line. Okay, and so if you look back at PO18 here, okay, we've got two functions when we started talking about function notation here. One of them is a linear function, the other one isn't. Okay, and the one that isn't is the one that's not a line. F of x there, that U shape. Nope, not yet. Nope. You're on my schedule now. You had plenty of time earlier to get that pencil sharpened. You did not.
I didn't open it up.
So the U-shaped one, not a linear function. It's not a line. Okay. Whereas g of x, that purple one, is a line, and that would be a linear function. Both are functions, but only one of them. Open up your binder, please. Only one of them is linear. Okay. So after I write the definition down, those waiting to sharpen their pencil for the last time, because I'm going to accidentally break that after class. Linear function is a function with slope. And I'm not done yet.
I need my pencil.
Don't care. Oh, hold on. I should do this. A function with slope. And if you remember, slope last year, we talked about slope, we defined slope, we had a formula for slope, we graphed with slope. Basically, something that has slope means it is a line. Now you may sharpen.
Oh my goodness. Why isn't it working now? It's not even working.
Good.
You broke it.
It's not even like working.
Hey, let me do it.
Oh wait, it kind of works. Not really though.
Texting my mom, let her know what I'm up to.
Yeah, if we're not.
Do you have an agent? Zoe?
What?
Do you have an agent like I do? I have to be at the ready for the phone call.
Well, it's not fair. Then happy birthday. Yeah.
So, linear functions and slope go hand in hand, okay? Every linear, boys, this is the key here. Every linear function has slope. Meaning that if you can determine a relation has slope, that's how you determine whether or not it's a linear function. If slope exists, it is a linear function. If slope does not exist, it is not a linear function. A linear function must have slope. So that brings us to slope. How would you define it? Again, we've worked with this several different contexts last year. Like you've heard the word before, but how would you define it? No, wait. Rise over run. Okay. Rise over run is a common phrase or a common thing that's used to define slope. How else? Yeah.
Y2 minus Y1.
Sure, we have the slope formula. Y2 minus Y1 over X2 minus X1, right? That was one of your entrance exam objectives where you had to find the slope given two ordered pairs. And that's the formula that you probably used. Excellent. What else? Yeah.
Oh, length over width.
Not so much. Length and width there. Yeah.
Oh, range over height.
Again, you're. I think your head's in the right place, but not mathematically, not using quite the right words. If you're going to talk about that, like when you talk about rise, that's kind of your vertical, right? The height,
Oh yeah,
so to speak.
vertical over
Horizontal, right? And how we would write that is the vertical change over the horizontal change. Okay, the vertical change over the horizontal change. I just want to check with Darth. Thanks, Darth. And so really what that is saying, like another way to write vertical change over horizontal change is this change in y over change in x. And that is really what you're going to be looking for. Okay? Is the change in y over the change in x consistent? If it is, it's got slope, therefore linear function. If it's not, it doesn't have slope, therefore not a linear function. So all we're going to do is we're going to look at these y values here, and what's the change from -3 to -1? What's the change from -3 to -1? Yeah.
+2.
+2, right? You're going up 2 to get from -3 to -1. How about from -1 to +1? What does that change?
+2.
+2 again. I like where we're headed. How about from +1 to +3? +2. Okay? So the change in y is consistent throughout. That's a good sign, but we have to check the x also. So what is the change in x from +1 to +2? Up by 1. So the slope that we're looking for here is 2 over 1. The change in y over the change in x is 2 over 1 for our first set of ordered pairs. We have to make sure that our other two ordered pairs match it. So, hey, what is the change from +2 to +3? 1. And finally, what is the change from +3 to +4? Scarlett? 1. So because all of these are consistent, +2, +1, +2, +1, +2, +1, is it linear?
Yeah.
Yes, because that change in y over change in x is consistent. And not only that, but we also just figured out what the slope is. The slope is 2 over 1. We're being so productive today. We're nailing slope and we're determining linearity. It's fantastic. What's another one you want to do together? Nolan.
This one.
That doesn't help me.
Oh, the bottom. Oh, the bottom. Second.
In this row here, we'll get down to the second.
Oh, the third one.
Third one, okay. So here we've got 548, 1056. And also, let's start at the basics. Is this relation a function to start with? Because if it's not even a function to begin with, it can't be a linear function. So first things first, is it a function? It is, because x does not repeat itself, right? So now we can proceed. Let's look at the change in y. What's the change from 48 to 56? +8. What's the change from 56 to 72? Bless you. 16. I'm a little nervous, but let's continue. What's the change from 72 to 80?
8.
+8. Okay. Now, just because that change isn't consistent doesn't mean you can stop. Because remember, slope is a fraction. So when you look at the x's and you say, what's the change from 5 to 10? And you say +5, that means that your three slopes have to be the same as or equivalent to 8 over 5. That's the change in y or change in x of our first set of ordered pairs. The other two have to match it. Now we've got this jump of 16 here, but when you look at what's happening in the x column, what's the change from 10 to 20? Up by 10. And so if we put those in their places, a change of y of 16 and a change of x of 10, are those two fractions equivalent? 8/5 and 16/10?
Yeah.
Yes. Which means, are we still in business for a linear function?
Yeah.
Indeed we are. Okay? So where kids go wrong on a test with this is they stop too soon. They think all I have to find is a difference. If anything's different, there's no slope. That's not the case. You've got to check them all. Okay? And then the difference from 20 to 25 is +5. We're back to our +8 over +5. Because these fractions are all the same, they all simplify to be 8/5. Slope exists, and it is indeed linear. Isn't this fun?
Yeah. So fun, yeah.
Tristan?
Oh, can we do the second one next?
Sure. Any more questions on this one? Okay. Second one. Same kind of deal here. we're looking for the change in y from 0 to 2 is up 2. From 2 to 4, up 2. From 4 to 6, up 2. So far, so good. But we still have to check the x's. 12 to 15 plus 3. And so this is what we're looking for here. We're looking for change in y of 2, change in x of 3 consistently. We have all the 2's. Now we have to confirm the 3's. 15 to 18 plus 3. 18 and 21 plus 3. The slope is 2 over 3, and it is indeed linear. Yay! Yeah, who is that? Thank you for the enthusiasm. Yeah. Okay. Let's look at the bottom row. This one you can do for homework. And in the bottom row, we've got 2 on the coordinate plane. We have 2 tables. I'll have you do the tables on your own because we've already done several of them. But let's look at those graphs. Again, the definition of a linear function is it's a line. It has slope. Do either of these, or both of them, or neither of them meet that criteria? No what? I asked like 3 different things.
No, they do.
They do. So you're saying the first one has slope?
Well, which one's the first one?
Yeah, the one that comes before the second one would be the first one.
Right, yeah.
Yeah. Yes. Okay. If we kind of move along from point to point here, right? We're going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Look at that nice staircase it makes. Consistent. The change in y is consistently going up 1. The change in x, the horizontal, is consistently going over 2. So this is indeed linear. But if you look at that second one, something happens at that vertex of that v there, right? We start by going down 1 over 1, down 1 over 1, but then what happens? We start by going down 1 over 1, down 1 over 1, but how do I get to my next point now? Can I go down 1 over 1 again?
No.
What do I got to do?
You go up.
Up 1, right? In order to get to that next point, I've got to go up 1 over 1, up 1 over 1. Something changed. That's not a staircase, right? That's not consistent. Okay? So this one would be not linear because there's no consistent change in y or change in x. There's no consistent slope. Right? So your homework is to do the rest of the tables that we did not talk about. The 2 brain busters at the bottom. I give you a particular slope and I have you make a function table with that slope, make it a linear function. So let's just look at the first one. It says make an xy table with at least 4 ordered pairs of a linear function with a slope of -2 over 7. Okay, so here's our function table, there's our x, there's our y. Does it matter which number that negative sign goes with
No.
in a fraction? It doesn't. It's typically put with the numerator. So if you read this, we're looking for a change in y of -2, because we're going to put that sign with the numerator, and a change in x of +7. They're not both negative, because a negative divided by a negative is a positive, which is not what we have here. So change in y of -2, change of x of 7. Adrian, give me a number 1 through 100.
97.
97. Great. Tristan, give me a number 1 through 100.
95.
95. Okay? So if this is an ordered pair of this relation that we want to be a linear function that has the given slope of -2/7, which means that our change in y is consistently going down 2, what's this next number going to be in the y column? Anthony? 93, right? We went down 2. What's the next number going to be in the x column?
104.
104. We went up 7, right? And this is just a sample answer. No matter what numbers they originally picked, the y is just going to go down by 2, and the x is going to go up by 7. What would the next number be in the y column?
91 and 8.
91, down 2 again. What's the next number in the x column? 111, up by 7 again. Now I wrote too big, so I can only fit 3 of them, but you gotta fit 4, at least 4. You can go all weekend long if you want. Okay. And then the next one, very similar. This time a slope of 5/4, which means your y is a change of positive 5, right? And your x is a change of positive 4. And you're making an x, y table, function table with those values. Then there's time for review down at the bottom. How can you determine if a relation is a function? And for f of x equals 7x plus 12, find f of 5. Reviewing what number are you being given, what do you plug it in for, how you solve it, etc., etc. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. Sweet. All right, you've got 10 minutes to work. I see no reason why we can't start for our second number game reward day on Monday when this is due. Don't forget about the math packets. Don't forget about Khan Academy. There's nothing due this coming Thursday. It's due the following Thursday, but it's still out there for Taiwan. Hey,
Question.
yes.
When do we get our reward?
Probably. I have to look at where I can DoorDash from, or if I want to drive out.
Where are we getting it?
Donuts. 75% of you said donuts.
Oh, okay.
If you have a dietary reasoning for not getting a donut, let me know. If you're allergic to something in donuts or whatever, dietary.
So if I'm like on a bowl for a cut.
If you're what?
On a bowl for a cut.
Yeah, I'll get you a carrot. Okay.
Well, then I'm on a bowl.
All right, that's what I'm at.
Don't forget to like and subscribe.